All right, welcome again to Good Choices. So we've got something that really confused me. So this whole lesson one is pretty confusing. The way this is organized is with topics. So we made it all the way through topic 101 and topic 102. Topic 101 was about system architecture. Topic 102 was about Linux installation and package management. So we're on to topic 3 now. GNU and Linux commands, if we remember that from the last video. So within each topic, there are subtopics denoted with this dot notation. So the first subtopic in system architecture is to determine and configure hardware settings. But then where it gets confusing is there's actually lessons within each subtopic. So and the reason it's confusing is because we've only had one lesson within each subtopic, but now we're going to have two lessons within some of the subtopics. Some of them still only have one lesson, but in this subtopic 103, GNU and Unix commands, in more lessons than not, there are going to be in more subtopics than not, there are going to be two lessons. And that's where I'm getting confused. I would think of these topics here as lessons, or the subtopics as lessons. So I think I labeled all of my videos correctly. If I look at my full playlist, we've got the subtopic, the topic here, and then the subtopic. So these are all lesson one. And then I have the parts I split them in. So it's going to get a little bit confusing because we're going to see the topic and the subtopic remain the same, but then we're going to see lesson 2, and then if there's multiple parts, we'll see multiple parts there. But it shouldn't get too confusing. All you need to know is what's here in order to follow along. So you should be able to line up pretty easily what the video is and how it aligns to this documentation. But it just confused me quite a bit. I actually thought I was shooting the wrong content here, but everything looks good to go. So no time to waste. So this is topic 103, subtopic 1, and it's lesson 2 of the subtopic. The subtopic is working on the command line, and the topic is GNU and Linux command. So the first lesson we had was the objective was also to work on the command line. We went over basic navigation through the command line, some basic optimizations like using the history, some basic inspection commands about like what kind of commands they are. We learned about hashing. So let's move on to lesson 2 and the introduction. An operating system environment includes the basic tools like command line shells and sometimes a GUI that you will need in order to get stuff done. But your environment will also come with a catalog of shortcuts and preset values. Here is where we will learn how to list, invoke, and manage those values. So finding your environment variables. And I'll get my home lab up before we continue. And I won't need to enter a password because we already learned something really awesome. And the reason I don't need to enter my password is because the SSH copy ID command, and then you feed it where your .ssh public key, and then you do the where you want to log in. Save me a lot of hassle. So just how do we identify the current values for each of our environment variables. One way is through the env command. All right, let's try that out. There we go. Let's see if any are different. Let's see if we're looking at the same debug topics. Oh, I don't have any debug topics at all. Okay, well, that's interesting. That was kind of the goal. You will get a lot of output, much more than what is included in the above excerpt. But for now, note the path entry, which contains the directories where your shell and other programs will look for other programs without having to specify a complete path. With that set, okay, so for now, note the path entry, which contains the directories where your shell and other programs will look for other programs without having to specify a complete path. With your path entry set, you could run a binary program that lives, say, in /user/local/bin from within your home directory, and it would run just as though the file was local. Let us change the subject for a minute and talk about balloons and how they float through the sky and how magic that is, and that'll take us to the magical world of helium and Gaussian science and molds and all that. Let's talk about chemistry. Oh, actually, it looks like we're going to be talking about the echo command instead. The echo command will print to the screen whatever you tell it to. Believe it or not, there will be many things or many times when getting echo to literally repeat something will be very useful. But there is something else you can do with echo when you feed it the name of an environment variable and tell it that this is a variable by prefixing the variable name with a $sign. Then instead of just printing the variable's name, the shell will expand it, giving you the value. Not sure whether your favorite directory is currently in the path? You can quickly check it by running through echo. So let's see if my favorite directory is in the path. I don't really have a favorite directory. Maybe my home directory is my favorite directory. Oh, and there it is. Okay. Well, it looks like my phone directory actually isn't in the directory. It's just bin directory. Yeah. And this games directory's in there. I wonder if I have any games on here. Oops, I didn't get that in my clipboard. No games. It's all fun and games until your /user/local/games directory is empty. Oh, it's not even a directory anymore. Oh, I see. Okay. Yep. I got nothing. Creating new environment variables. You can add your own custom variables to your environment. The simplest way is to use the equal character. The string to the left will be the name of your new variable, and the string to the right will be its value. You can now feed the variable name to echo to confirm it worked. All right, so this is like bash scripting stuff. If we're familiar with Python, we can do the same thing. So we can do the same thing by doing this. So we can do my var, and we don't need spaces, but I like how spaces look, so we'll keep that there. And now it's different because to define a string you need to wrap it in single, double, triple. You need to wrap it in quotes, whether it's single quotes or double quotes. For multi-line strings, you use a set of 3 of whichever character you choose. And now instead of echoing it, we do print. There we go, and that's what we're going to be doing, but we're going to do it in Bash instead. So let's do it. There you go. Now, one of my favorite things in Python is this type command, because it tells you information about your variables. That's really useful. So in this case, the variable is not defined. If we define it like this and the new type, then we can see it's an int. If we redefine it like this, we can see it's a string. If we define it like this, you can see it's a bool, and like this, you can see it's a none type. So I like doing that because it really gets you a sense of your variables that you're working with. It's important to know what kinds of data types you're working with. So let's see. I know that there's a type command in Bash. So let's see what happens if I run that for the variable we just defined. Okay, so it looks like. Okay, so it doesn't work the same way. It's a totally different command. Let's do a quick man on it to get a sense of what that is. There's not even a manual entry for it because it's a built-in command. But we can get a help on it. So indicate how it would be interpreted if it were used as a command name. That's what that is. So we could probably do a type on type. Yeah, and we know that it's a shell built in. Okay, so no similarities there. Bash scripting is its own language. The similarities end with Python pretty quick. Notice that there is no space on either side of the equal sign during variable assignment, which might be weird to get used to if you're used to Python. But did it really work? Type bash into the terminal to open a new bash shell. This new shell looks exactly like the one you were just in, but is actually a child of the original one, which we call the parent. Now inside this child shell, try to get, and I'm not going to look at the rest, try to get echo to do its magic the way it did before. Nothing. What is going on? This is a really good point. Like I can't say enough how impressed I am with this cert so far. I'm learning this all for free. I'm putting it all out there on my YouTube channel, making videos, and I'm learning new things. I learned how to set up public key authentication to my lab. I learned about the UEFI boot up process. I was really shaky on that. Don't really remember that much. I've learned this. So if we do the echo my var, okay, and now we open a new shell, echo my var, nothing. It's not defined, and that's because it's a whole new shell. It's not the same. We defined it in the shell we're in here. We did not define it in another shell. So let's say you and the way we defined it, if you'll remember, is we did this here. We did my var equals hello. So what if you want it to persist through all your child shells? Export. That's how you do it. So export my var equals, and I forget what we defined it as before. I'll stick with the same thing. Var equals, and you don't need quotes because this is Bash scripting, not Python scripting. Okay, so now what happens if we echo that? We get the same thing. Now here's the key. Come on. Oh, we're not showing the. Oh, okay. Well, I guess I got a lot to learn then because this didn't work the way I expected. I thought the export command did that. Um, okay, well, I've got a lot to learn. It's a good thing I'm reading this then. So a variable you create the way we just did is only going to be available locally within the immediate shell session. If you start up a new shell or close down the session using exit, the variable will not go along with you. Typing exit here will take you back to your original parent shell, which right now is where we want to be. You can run echo myvar once again if you'd like, just to confirm that the variable is still valid. I guess I forgot to do that, so let's do that. Echo myvar. There it is. Bash. Echo myvar. There it isn't because we're in a child shell. Back to the original. Echo myvar. And there it is because we're now in the parent shell. Now type export myvar to pass the variable to any child shells that you may subsequently open. Try it out. Type bash for a new shell, then echo. So let's see what I tried to do, because I was right that the command was export, but it looks like I didn't do it correctly. So okay, so in command 1878 that I issued in my history, we can see I did the echo myvar. Then I did okay, I'm confused here. I did this, so it looks like I did, I exported, when I did the export statement, so I'm going to grep it out just for when I did the export, and I only did the export statement once. What I ended up, my syntax was all off. I was, that's not the fact is that my understanding of the bash scripting language was not very good, because I didn't export a variable. I exported the syntax to call the variable. I exported a syntax that makes no sense. And let's just try that syntax without the export statement. And we get an error. We get command not found. So the syntax was completely wrong. If we do myvar like that, yeah, so what we're doing is we're typing out hello and issuing a command. If we want to see what the var was defined at, we use that echo so that we're not actually entering in whatever happens to be in there and pressing enter and passing it to bash as if it were a command. That's bad. You could end up doing stuff you don't want to do. So where I went wrong is I made a syntax error. I passed in a completely invalid series of characters. So I was on the right track though. So let's do the echo myvar. There we go, it's defined. Now let's do bash echo myvar. There we go, it's undefined. Exit echo myvar. There it's defined. Now we'll do export no $, myvar, because we're not calling the variable, we're doing an action upon the variable itself and not the result of the variable. So we don't need that $. There we go, that went good. So now let's do echo myvar. There it is. Now let's do bash echo myvar. And there it is again, because we exported it to all child shells. All right, all this may feel a bit silly when we are creating shells for no real purpose, but understand how shell variables are propagated through your system. Understanding how shell variables are propagated through your system will become very important once you start writing serious scripts. Okay, so I'm going to exit out of this extra shell, clear it up, and take a quick break. And when we come back, we'll be learning about deleting environment variables. All right, I'm back. Moving on, deleting environment variables. Want to know how to clean up all those ephemeral variables you have created. Ephemeral means basically like random and it basically just means random. One way, random and short-lived. One way, like whose purpose is not, like you can have something that's random, but they have a definitive long-term purpose. Ephemeral is like something that's random, but doesn't have a purpose beyond its short-term use. One way is to simply close your parent shell or reboot your computer. But there are simpler ways, like for instance, unset. Typing unset without the $sign will kill the variable. Echo will now prove that. So let's do that. So unset my var. All right, echo my var. There we go. And let's go one step more and do a bash and see if it unsets it in the child shell as well. And it does. If there is an unset command, then you can bet there must be a set command to go with it. Running set by itself will display lots of output, but it is really not all that different from what the env command gave you. Look at the first line of output you will get when you filter for path. All right, so here's the first line we get. So let's take a look at env. Okay, and then set. All right, we get a lot of outputs. So now let's filter set. Okay, so the first line we get something similar to the learning material. What is the difference between set and env? So let's figure it out. So env help set help. So it looks like env sets each name to value in the environment, and so I guess we have a full documentation here. So we have a command line here. Or sorry, we have an internet connection, so we can look at command line help online. I think I'm just going to stick to the learning materials. Those are pretty good. This is let's see if they have set on here. Nope, this is just the documentation for env. So we'll get 2 and 1 if we just continue with the learning materials. For our purposes, the main thing is that set will output all variables and functions. Let us illustrate that. We will create a new variable called myNewVar and then confirm it is there. All right, let's go ahead with that. So myNewVar equals goodbye, echo myNewVar. Okay. Now running env while using grep to filter for the string myNewVar will not display any output. But running set the same way will show us our local variable. Okay, interesting. Huh. Yeah, it's not supposed to show up in env. And there it is in set. Interesting. I'm trying it in a new bash shell. It's not set in there. All right, so it's kind of, the point is kind of lost on me. So let's go to the AI, or we can just ask it right here. So I'm gonna say, okay, to the AI. There we go. I'm going to say the point is lost on me. What is the difference between set and env? So here we go. This looks good. So let me clarify the difference between set and env. The set command is used to display all shell variables and functions. It provides a list of all variables and functions that are currently defined within the shell session. This includes local variables specific to the current session, environment variables, shell options, and defined functions. The env command, short for environment, is used to display the environment variables specifically. Environment variables are a set of variables that are available to all processes or commands running within the current shell session. These variables are inherited by child processes from their parent processes and can be accessed by any program or script, including within the system. In summary, the main difference between set and env is the scope of variables they display. Set shows all variables and functions within the current shell session, including local variables, environment variables, and defined functions. Env specifically displays the environment variables that are inherited by child processes from their parent processes. And it looks like the default is pretty good as well. So let's read that. In the context of shell scripting or command line usage, the difference between set and env lies in the scope of the variables and functions they display. The set command is used to display all shell variables and functions, including local variables specific to the current shell session. When you run set, it will output a list of all these variables and functions. In the provided example, running set pipe grep myNewVar displays the local variable myNewVar and its value function. On the other hand, the env command shows the environment variables for the current shell session. Environment variables are variables that are inherited by child processes from their parent processes. For example, when you run env pipe myNewVar, you won't see any output because myNewVar is a local variable specific to the current shell session, not an environment variable. Okay. To summarize, set lists all variables and functions, including local ones, while env shows only the environment variables. So let me try this to make sure that I understand it. So I'm going to do test equals test, and I'm going to do echo on test. We should see test. Okay, then I'm going to do open a new shell, bash, echo on test. Okay, so we don't see test. Then I'm going to do env in this new shell, piping out for test, or grep, yep. Okay, so we don't see it. Then I'll do set, piping out for test. We don't see it. We see test showing up, but it's not relevant. Okay, so now let's go back to the original shell and do echo out test again. There we go. And then we'll do env pipe grep for test. Nothing showing up. And then set pipe grep for test. And there we go. This is a parent process, not a child process. So let's see if we can get it showing up in env via the env command. So to do that, as far as I know, you would go export, and we're going to export the variable we defined earlier, which was named test. Okay, so now let's try env pipe grep test, and there it is. And then let's do set pipe grep test, and there it is. So then now let's open a new shell and do env pipe grep test. There we go. And then set pipe grep test, and there we go. So that's the difference. Then we'll do an unset on test, and do those same things again. Env, nope, not there. Set, nope, not there. If we open a new bash, env, nope. Set, nope. Alright, so next section, quoting to escape special characters. I need another break. I'll be back shortly. Alright, welcome back. Let's try to get as far as we can here. So next section is quoting to, sweet, we can finish this up. So next section, quoting to escape special characters. Now is as good a time as any other to introduce you to the problem of special characters, which we already know from Python. I'm a competent Python programmer, so this is great that I'm learning a second programming language. I'm learning Bash to a higher degree than I knew it. Alphanumeric characters, A through Z, looks like it's lowercase. I don't know if uppercase is included as well. And 0 through 9. 0 through 9 is a numeric character. A through Z is alpha characters. So these are alphanumeric characters. Will normally be read literally by Bash. If you try to create a new file called myfile, you would just type touch followed by myfile, and Bash will know what to do with it because these are all alphanumeric characters. But if you want to include a special character in your file, you will need to do a bit more work. To illustrate this, we will type touch and follow it by the title my big file. The problem is that there are two spaces between words which Bash will interpret. While technically you would not call a space a character, it is like one in the sense that Bash will not read it literally. If you list the contents of your current directory rather than one file called my big file, you will see three files named respectively my, big, and file. This is because Bash thought you wanted to create multiple files whose names you are passing in a list. All right. So touch, clear, touch, my big file, ls. Yep, we've got my, we've got big, and we've got file. So let's remove all of them. And look at that again. There we go. These spaces will be interpreted in the same way if you delete rm all three files in one command. Now let us try it the right way. Type touch and the three parts of your file name, but this time enclose the name in quotation marks. This time it worked. Listing the directory contents will show you a single file with the proper name. All right, let's try that. And there we go. There are other ways to get the same effect. Single quotes, for instance, just like Python, work just as well as double quotes. Note that single quotes will preserve the literal value of all characters, while double quotes will preserve all characters except for the $, this special tick sign there, and the backslash, and in certain cases the exclamation point. So it's not quite like Python. In Python, yeah, it's quite a bit different from Python actually, because in Python you have to wrap it into strings always. So it's almost like this escape character is like wrapping it in strings. In Python, it's a backslash. Yeah, it's like quite a bit different from Python. That might take some getting used to. Anyways, let's remove the file. And we'll use single quotes this time, like in the example. And there we go, file's removed. Alright, so prepending each special character with a backslash will escape the specialness of the character and cause bash to read it literally. So let's try creating that file again, but instead of wrapping it in quotes like we did before here, we're just gonna escape each individual special character that is not automatically parsed as belonging to a part of the same string. And this is just like Python with a backslash. And there we go. We got the same thing, my big file. We can remove it in the same way. There we go, and it's removed. Alright, so on to the guided exercises. Use the export command to add a new directory to your path. This will not survive a reboot. Okay, so a new directory here. Let's see here. So let's do export a new directory to my path. So let's add this wet bulb directory. I tried to make this project kind of like a COVID tracker where we would like track cases, but it was like a weather application where you could track wet bulb temperatures. So a wet bulb temperature is or wet bulb weather condition. A wet bulb weather condition is a weather condition where your body's natural cooling systems, instead of cooling you down, they heat you up. And you can only survive wet bulb temperatures for a few minutes before you die, because your body just cooks itself like an oven, kind of like steamed, like you get steamed to death. So wet bulb temperatures are, let's see here, I have it there. Wet bulb temperatures are above 90 degrees with a humidity above 90 degrees, greater than or equal. So it could be 95 at the lowest, but you have to remain indoors in an air-conditioned environment until the weather conditions improve. You know, this is rare. It's only found in certain parts of the world, but I'm going to say it, global warming is real, and as a result, this is becoming more and more common. So something like this, especially as we move forward in time, you know, I'm going to be ahead of the curve by quite a bit by having a tool like this, and my tool might even get popular depending on if these conditions become worse and worse over time. So like this is a great project I've been working on. Unfortunately, you have to buy an API here to like this weather thing if you really want it to work. And I'm just not a big fan of, like, you know, I mean, that's probably a good way to spend, but I don't want to spend money on that API, especially when the tools, like, you know, I could have spent money on this API, stopped with this project, and then not finish the project and then have lost money to it. So yeah, the other thing to be really aware of with wet bulb temperatures is that it doesn't matter how healthy you are. In fact, if you're healthier, you could be even more at risk because you're more physically active, and your body will use those cooling systems more effectively. So you know, the point of a wet bulb condition is that your body no longer can do the things it was designed to do because it's operating in a weather condition that it is not it doesn't have any defenses for. So you're gonna die if you're in wet bulb weather and you're not inside in the air conditioning. But the good news, this is rare and it's isolated to only certain parts of the world, really. The bad news is it's becoming less and less rare. So let's see if we can use this as the new directory to my path. So use the export command to add a new directory to your path. This will not survive a reboot. So we're gonna add this one to it, and we're gonna add it to my path. So let's do echo path. All right, I don't see it there. So let's do export wet, and then let's give it the full. Yeah, so we're gonna do export home gposh, and I can't auto complete it, but that's okay. I'll just type it out. Oh, it's not a valid identifier. Did I spell everything right? I guess what I could do is not even worry about whether I spelled it right again and just try it again like that. Same thing, not a valid identifier. I guess maybe I could do this. So path, so I can do path equals, and then type it out. And now I can do export path. And now let's see if this shows up in my path. Echo path. And it doesn't. Oh shoot. So I don't know. I don't even know how to do this. What about set? Okay, well, I guess I don't know the answer to this. Let's look it up. I'm kind of surprised this beat me so bad. Oh, okay. It's actually a pretty sophisticated answer. So you can temporarily add a new directory, perhaps one called My Files that lives in your home directory, to your path using. Okay, so I kind of got close here. Using so I was on the right track. Let me take a look at the commands I put in. So I put in the export command. I did that. I tried to do that here, but it wasn't valid. So then I defined the path. That wasn't valid either. Let's try just let's do make dir my files, and then let's do export path equals home gosh my files path. Does this work? And then echo path. Oh, there it is. Yeah, I wouldn't have known how to do that from the reading. So I guess we're learning about it brand new in the guided exercise. All right, so create a simple script in the my files directory, make it executable, and then try to run it from a different directory. These commands assume you're in your home directory, which contains a directory called my files, and I am. Uh, so now here's where it gets confusing as well because they're not. So I have to make a. Ow. Oh my god. Ow. Okay, hold on a second. Okay, I am back. So let's see here. Assume that you're in your home directory, which contains. Okay, so we got to create a simple script and makes it executable. And then run it. So. I guess it doesn't have to have anything in it. So, yeah, we're just making a blank file that has the .sh extension. So that's the extension that makes it a bash scripting file. So we're just doing that, and it's going to be blank. It looks like we don't have. I missed an S here. There we go. Bin bash my files my script.sh. There we go. My files. And that looks like a capital X to me. Okay, and we did add some stuff to the file. We added this. So if I cat out that file, we can see the lines that I added to the script. So cat my files, my script. There we go. So last step is to run the script. Permission denied. You probably need that's probably coming from the fact that it's a .h extension. That's weird. Why is the... Wait, I don't get it. It's not auto-completing. Permission denied. That's so weird that it's not auto-completed. Command not found. Okay, well, I mean, if we tell it that we're running it in bash, then it works. That should be taken care of by this. Oh, you know what? Maybe this was a lowercase x. Let's do a ls-l. Yeah, I think it was a lowercase x because we see we don't have these executable permissions. So let me try that again with a lowercase. I must have... Oh, I'm already in the my files directory, so I don't need to specify this. Okay. And there we go. That was the problem. There was a lowercase x. Now if we do a ls-l, we see we do have executable permissions on there, so we can run this as an executable. Since we're running it as an executable, we don't need to specify that we're using bash because it's an executable file, and we can see what program we want to execute the file with in the shebang statement here, which is the first line in the script. And then since it knows via that shebang, and it is an executable, the first thing it reads is that and knows to use it with bash. In addition, an advantage we got is since we added it to that path, now we can run it from anywhere on the system because it knows where it is, since it's defined. Since it's defined in my path. So I do echo path. My files, I think it's because of this. Let's try removing that and see if we can't run it from here. So let's see here. We did the yeah, we did this export there. So now we can do the unset command, as far as I know. I thought we could do that. Okay. Oh, that's probably very bad. But anyways, that kind of accomplishes what I wanted to test. So now let's test script.sh. There we go. So we can't run it in the same way we ran it before because it doesn't exist in the path. I deleted everything in the path, which is probably not a good thing. But you can see if I add it back to the path and we take a look at what's in my path now, we do have that there. Now I can run it because it knows where it is, independent of where I am, because it's a part of the path. All right, so guided exercise number 2, and I think that's everything. Yep, no more reading associated with that. So guided exercise number 2, use the unset command to delete the path variable, which I tried doing and it didn't work. Oh man. Try running a command like sudo cat etc shadow using sudo what happened and why. So the existing shell, exiting the shell will so I think we actually did this. We unset the path variables. So let's take a look at what I did in my history. Yep, we unset the whole path. So this is what the next guided exercise would have had us do anyway. Is unset the whole path variable. So we can see in command 2023 I reset that. So you know what, let's unset the whole path variable again because it is part of this guided exercise. To unset the variable, you need to use the name of the variable without the $, because the $, calls the value of the variable. We're not concerned with that. We're concerned with the variable itself. All right, so we unset the variable itself. You can see we've got nothing in the path now. So let's try running this command here, sudo cat shadow. And there's no such file or directory because independent of our present working directory, which happens to be home gposh, we have no way of determining where this shadow is. And if we were to move into the etc directory, undo sudo cat shadow. Oh, it doesn't know. Oh, you know what? It's because it doesn't know about sudo, I think. So we could do. Oh, it doesn't even know about cat. Yeah, this is problematic because like we blew away everything, so it doesn't even know about the directory that sudo and cat belong to. So let's it doesn't even know. It probably only knows about built-in commands, if it even knows about that. So what are some built-in commands? Type is a built-in command. Does it know about that? It does know about that. So let's do type on shadow. And yeah, I can't even find it. Type on sudo. Can't even find that either. So like the type command still works because it's a built-in command. We can do a type on type and see that. Um, we can probably even do so man is I think also a built-in. No, it's not. Okay, wow. So if we go to bin here, that's where all this stuff is. So I'm pretty sure if we do, whoops, I messed up. Oh, and now everything's back to normal anyway because I started a new shell. So that's kind of what I wanted anyways. So now you can see, it knows where all these commands are. These commands are in, wherever they are, probably user sbin. So ls pipe grep for sudo. So that one's not in there. Yeah, it's probably in /bin is where it is. Let's take a look. Not in there. Interesting. Not in there either. Okay, so I mean I don't know where that is. Uh Maybe it's in sbin? Interesting. Uh Really interesting. Yeah, I'm not sure where that is. I'm tempted to just look through all of them because I'm curious about where it is. Now we have these commands like which though. So let's try that. There we go. When we found it, it's in user sbin. Or sorry, user bin, not user sbin. There we go. Yeah, it's showing up. So that's just one of the ones on here that I haven't checked yet. We can see user bin is right here. It's the one that's word wrapped too, so it's kind of harder to see than the others. All right, so let's take a look at the answer to this second guided exercise. So the question was, use the unset command to delete the path variable and try running a command using sudo. What happened? Why? So my answer is that it fails to find this command sudo because it's not defined anywhere in your path. So you can do that. So we can do unset on the path here. And now that oh, sorry. Perfect. Okay, and now that we're actually in here, now we can do a sudo. But if we're elsewhere, we can't do a sudo because it doesn't know where sudo is without that path variables being set. So now that the path variable is set, we can do sudo from anywhere on the system, and it knows where to find it. That's my answer. Let's see what the official answer is. Typing unset path will erase the current path settings. Trying to invoke a binary without its absolute address will fail, but its relative address will succeed, as we saw. For that reason, trying to actually does its relative. Let's see that. So I'm kind of curious about that. So echo path. There we go. And then we know that bin is in or sorry, sudo is here. Ls pipe grep sudo. Yep, it's there. So now let's do unset path, and then echo path. So we got nothing there now. Sudo, still got it. Let's go back. Sudo, don't have it now. So let's try to tell it where it is by saying /bin, or it's by giving it the relative path to where it is. So where we are is here /user, and we know it's in bin sudo. There we go, and that works. The other thing we could do is do the absolute path. Okay, so you can see the whole point of that path is so that it can find things without you having to explicitly tell them where it is. But the good news is if you don't have this path set up, as we do not here, but I will revert that right now, you can still run everything on your system. You just have to tell it where the thing exists. It doesn't know in advance unless you have that path variable set up. Okay, so for that reason, trying to run a command using sudo, which itself is a binary program located in /user/bin/sudo, as we sudo, not doodoo. The command is sudo. Will fail unless you specify the absolute location, as in /user/bin/sudo/bin/cat/etc/shadow. You can reset your path using export or by simply exiting from the shell. So we did that. We exited the shell. We got back in. So if we take a look at the path, everything is set back to the way it was. And we know how to add more things in the path. Like, for example, that wet bulb project. If we want to run the files in here without having to specify, so if we go back and try to enter this, try to run the city ID collector.py, it has no idea where it is. But if we tell it where it is, it's in the wet. It's in the relative to the present working directory we're in. It's in wet bulb project. So now it knows where it is, but unfortunately it needs sudo permission in order to run a Python script. But did I enter that in right? City ID collector.py, command not found. I don't have the shebang. Yeah, I don't have the shebang, and it's probably not an executable as well. Yeah, it's not an executable, and I don't have a shebang, so that's why the command it doesn't know what command. So I can do I can tell it explicitly what command to use Python. And there's an error in the Python script, no doubt. I haven't worked on this in a while. It'd probably work if I used Python 3. Yeah, it does. Okay, yeah, so that's you know what? Why don't I just do that? Because that's something else that like we learned that is like really nice. So we're gonna come up to the top here. We're gonna add a new line to the top, and then it's gonna be the shebang line. So this line here, but instead of bin bash, it's gonna be it's going to be wherever that Python 3 executable is, which we actually need to figure out. But we know how to do that. We're going to do which Python 3, and there we go, user bin Python 3. So now we can go back into this. I'll just do a sudo just in case. Sometimes it's annoying that if you can't save it. So save myself that annoyance. And then I remember it's user bin Python 3. There we go. So that's the first step. And then the second step, we need to make it an executable. So we're going to go change. I'm going to go into the wet bulb directory because make it a little easier. And we're going to go change mod plus sign lowercase x, and then city ID collector. No, I meant change mod. I did a cd mod instead of chmod. Okay, there we go. So now I can go back to my home and I can run the. Oh, actually, I know I can't. Let's try it. So let's do city ID collector.py. Nope, command not found. So what we need to do is one final step here. We need to do this set command. Now we did make some progress. If I go into the wet bulb project, now I can run this city ID collector .py command. Oh, okay. Well, now I'm confused. Sudo maybe? Okay, well, I thought because it's an executable, I can run it without specifying that it has to be run with Python 3. But, oh, this is kind of fascinating. Is this, what is this printing out? I haven't worked on this in a long time. So it's writing out the city IDs? It's writing out city IDs that have wet bulb conditions? I am confused here. So where's it actually printing stuff? So it's printing out the city ID. Here. Okay, it's just printing every city ID it finds, and then it'll print out this if the city ID, if that city has a wet bulb condition. And unfortunately, it looks like I don't have it so that it actually prints out which city it is. It just works by city IDs, which is not so good. But anyway, it does not run as a executable, which is kind of annoying because I thought that would be the case. Yeah. You know what? You know why that is? You know why that is? It's part of this learning lesson. I should know why that is because of what we learned. So we're gonna do echo. We're gonna do this a $sign here. And we're gonna do path. So notice what's missing. Anyone? Yes, that's right. We don't have the Python. It doesn't know about that. The Python. So the shebang is useless because the shebang is saying that you use what to use to run the script, but since it's not in the path, it doesn't know how to access that. So yeah, let's update the path. So we're gonna do export path equals user bin Python 3 and then path. Okay, now let's take a look at echo path again. What the hell? Oh, that's bad. Okay. Well, so much for that. It looks like I blew away everything in my path. Instead of adding to my path, I just blew away everything. So I'm going to fix that by going back in. Echo path. Now I want to add to the path, not... How do I append to the path? You know what? Let's go to the AI for this. This kind of leaves a little bit to desired. They haven't really talked about that in a very clear way. So we don't have to spend money on this. Just go to the free one. There we go, pointing that in. And then we're going to say, how do I append the user bin Python 3? How do I append to this path? To my path. The path. Oh. So, here it is. Oh, interesting. Now, this is what it said to do, but we saw that it, so I'm gonna ask it, does that remove everything else in the path though? I want to add a new entry without removing any of the existing entries. Okay, so it says to use this instead. That looks like the same thing. So export path equals versus... Yeah, that looks like the same thing. Let's try it. Okay, that worked that time. So let's take a look at the command that I did before that didn't work the way I intended it to. I think wait. Yep. Yep. So see the difference between the two? Oh, wait. I thought it was the difference between single quotes and double quotes and how it's not exactly the same in Bash as it is in Python, but it looks like in both of these commands it uses double quotes, and I think in here it uses double quotes as well. So that was not a difference. That is so weird. What's the difference between these two? Besides... Oh, you know what? Maybe it is that. It's just that yeah, I think that is the difference actually, because I did not follow the learning materials. I did this on my own. So I think that is what happened actually. If I were to do this again and then echo path, yeah, that is the difference. So let's go back and read what the difference is between single quotes and double quotes, and we'll figure out what the problem was there. In the meantime, I will export this out and just prove that city ID collector.py still command not found because that's not in the path, but I can run Python 3 city ID collector.py, and it will fail because it can't find it. But if I go into here, then I can do that and it works. Um, which was always the case. It would always work if I would do that. The thing that is new is now I don't need to specify. What the heck? Okay, I'm really confused now because I thought because that shebang was on there and because it's an executable, um, and because this is in the path, I thought it wouldn't do this. Maybe it's because the project needs to be in the path as well. Let's try it. Yep. Okay, that's why. So the project needed to be in the path. So now we made it easy to run. So if I go to my home lab, I can do this. Yeah, look, it even auto completes it all. So that's how you get things nice and easy to run anywhere you are in your environment. You need to set up the directory that the thing you want to run in the path variables, but you also need to set up the thing you want to run it with. So I wanted to run this with Python 3, so I needed to add the folder where the Python 3 executable resides as well to my path. I needed both of those things in my path. So let's go back to home, clear, and take a look at my path. Echo path. And path, you don't have to be in home to path. You can be anywhere on the system to look at path. There we go. And we see the web project in there. We see Python 3 in there. I'll prove it to you. So we're here, echo path. There we go. It's the same information. So yeah, that was the confusion, is that it had to be anywhere. It had to include both the executable run used to run this file, so Python 3, and the folder that the file resides in, the web folder in my home folder. Okay, so the last thing I want to do is talk more about why I was confused there. And the reason was because I used single quotes instead of double quotes. And there's a reason there. So the reason why when I used single quotes, it blew away everything in my path. And when I used double quotes, it appended to my path, is because of the way single quotes and double quotes treat special characters differently. Double quotes will preserve all characters except for the dollar sign, which is used to call that variable. Single quotes will preserve the literal value of all characters. So let's do that again, but with single quotes here. So everything in my path is going to get blown away when I use the single quotes. And I first used that in command 1998, so we'll run that command again. And we'll take a look at my path. And Look at what's in my path. Is there anything unusual about this? 3, 2, 1. Okay, so here it is. This is now part of my path. And the reason is because I use single quotes. Every character here is taken literally. So this is a special character, or this is not a special character, but this is a special character, and we can see which are special characters that whose meaning are preserved here: the $, the tilde, the backslash, and sometimes that. So this is not a special character. It's an important part of the path. It's the way you differentiate different directories in the path, different absolute paths to directories. So this is a special character, though. This means that we're going to fill this in with the value of this variable path. But you can see that's not what happened. All we did is we put in the actual literal characters that were wrapped around this quote. And the reason that happened is because we used single quotes and not double quotes. So let's do it in single quotes now and see what happens. Or sorry, in double quotes now and see what happens. Okay, so now what we got is we have this added to our path, and we can see it gets added in the front. But now it's appended to what we had before. And why is that? Well, that's because if we if we look at what this was before we made the change, it was this, and we can see that is there with the literal characters being preserved as well. But here we don't have those literal characters because what we're specifying here is the value of this variable path, because we're using these double quotes and they preserve the special meaning of certain special characters. Here it's just the literal meaning of every character. So we got $path, not the value of the path variable. But here we do get the value of the path variable, which we saw up here. So we don't have $path in what we have here. This part of it does not mean the literal characters $PATH. It means the value of the path variable, which we see defined up here. All right, so last section of this is the explorational exercises. I need a quick break. I'll be right back. All right, welcome back. Really proud, really happy with how this video is turning out. I feel like we just went through some things that are really that are commonly misunderstood and just kind of done in a random way on Linux without any real knowledge behind it. So really happy with that. Let's try to close out this lesson all in one lesson by finishing up the explorational exercises. So the first exercise is to search the internet to find and explore a complete list of bash special characters. So you know what? This is so much easier. So print out a complete list of bash special characters. Now, to be fair, I will cross-reference this because the AI does hallucinate, but we can see here we've got, this looks, we've got 34. So let's see how many there are. Here we go. Special characters, Linux documentation project. This looks good to me. And it's not loading. Okay. How about Greg's wiki? That actually loads. It says here we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, only 19. But let's see if we add up the comma ones. So we got 20, 21, 22. Still 22. So maybe it is hallucinating some extra ones. Here's 23, 23. These are the deprecated ones. So yeah, it's kind of, maybe it's hallucinating. Maybe it's, I don't know. But I kind of like, when it hallucinates, it's not that big of a deal because you just try it and it doesn't work. Like, it's not that hard to disprove a hallucination. And then it's not a unique feature of AI either. People hallucinate just as much, if not more. And when they hallucinate, it's not necessarily in the same way. Like, I feel like the AI hallucinates in ways that are like, it's just trying to autocomplete words. Like, it's just a glorified autocomplete. So it's like, if it makes sense to write the words that it's using, because that's the most likely word to be spoken, like, it's useful to know that's the most probabilistically likely string of characters that would be used to talk about these sorts of things, even if it's just making up nonsense. Like, I find that useful to know that the AI considers that a appropriate thing to say, even if it's not incorrect. Whereas I don't find it that interesting when some random guy online, in between his Cheetos and Mountain Dew, just makes things up. Or somebody like me in between my what I got tea between my fancy food. All right, so here's all the characters. Yep. So let's explore just like a few of these. So the ampersand is used to run a command in the background. Okay, that'd be nice. So we've got this wet ball project I make that's just like running, and it's annoying. So let's try running it in the background, so we don't need to have that be there. So I lost all of my path settings, unfortunately. Restarted the shell. Kind of don't want to go through out there. This is where scripting is so powerful, though. So you know what? Let me demo that. So if we cat out the city ID collector, it actually looks like all of my path variables were blown away. So let's go back in. There we go. Let's do echo path. There we go. Now we've got them all back. So let's add in some path variables. So we're going to export. Now we're going to use double quotes, not single quotes, because we don't want each character to be taken literally. We want the special characters to be, their special meanings to be preserved. So we're going to add user bin Python 3, and now we can't forget to add the colon here, which separates out each element in this list of paths, and then this special character is preserved. So we're going to get the value of this path variable. There we go. And we need to add one more path here. So we're going to add home gposh wet bulb project. There we go. And now we can just run the city ID collector script without having to tell this system where it is. We already told it where it was in advance using those path variables. So let's try the new special character, the ampersand. Oh, nothing. Nothing. Okay, it doesn't work that way. So let's do tell me more about this. Oh, okay. You know what? I used to use this all the time. What this does is it just makes it so that let's do this. So like let's do the type command and if you want to run the type command twice, um, what you can do is use this ampersand, and then that second time it runs. So let's do like echo hello, and then the ampersand echo world, like that. Oh, that's the opposite of what I thought it would do. Okay. That's interesting. Ah, okay. Well, let's see what the AI said. Oh, yeah, yeah. Okay. So like let me do the wet bulb or city ID collector. So it's like for this city ID so like here's a good example. So I'll flip the order of these and it should make a lot of sense. So yeah, this should make a lot of sense. So now this script here, it takes forever to complete. So without this ampersand, we'd have to wait for this whole thing to get all the way through, which is going to take hours before we can run that next command. So instead, what you can do is you can run the commands asynchronously, where it doesn't depend on the state of the other command whether the next command can be run. And you can do that with ampersand, and we saw the result here. We printed out this hello world first because it's a shorter command that happened to run first. And even though we specified this as the command to run first, it ran second because it has a longer runtime. So if we were to just stop that, let's exit and get back in. Shoot, I forgot something. So one other thing that's that we can do. Let's see here. Like we can set up our bash RC. And I believe that we can modify the path in here so that it persists. Is it here or is it somewhere else? There's somewhere where we can modify the path so that it exists in there even if we exit the shell. Yeah, this looks like all about a lot of path stuff. So maybe this is a place. There's also .config. Maybe that's it. But anyways, what I wanted to demo, and I'm kind of short on time, is that you don't have to go through this process of modifying your path every time you go into a new shell. You can save it to a bash script and have that happen, or what you can do is save it to one of your hidden configuration files for bash, and have it automatically start without even having to run a bash script. But let's take a look at so we're going to pipe export. Oh wait, sorry. History, pipe grep export. There we go. And then let's just enter it back in like this. So we're going to enter in the one for Python 3, which is 1968. And then we'll enter the one for the wet bulb, Oops, sorry, we just blew away everything. Yep, okay. Alright, it's back now. So we're gonna enter history, pipe grep, export, and then we're gonna do 1973. All right, and then 1977, or sorry, 1975. All right, and now I should be able to do that city. There we go, without worrying about that. So now what should make this make extra sense is if we go on here and then we go there and then we go here, which would be like designating another line. So it's like running two commands on the same line, but we're not using that ampersand sign. So if I do echo hello world exclamation point, there we go. We don't see that hello world, and we're not going to see it until this is done. So if I do a Z on it, now we see the hello world. So you can see why that'd be problematic, because then you have to sit and wait for commands to finish before other commands are run, which could be good, but it also could be bad. If we instead use this ampersand, now we got that hello world right away, because that does not take as long to finish. So that's a good tip and trick to know. So let's just look at one other special character. I'm kind of low on time. Yep. So we've used this one a bunch of times. We use this for variable assignment. I guess the other one I wanna do is this one is a really classic one, important to know. So if we go back to my history of commands that I entered in, and then we see these two export statements that I used to set up that thing. So now we can say touch setup wet bulb dot or setup city ID, setup city ID collector dot sh. It's going to be a bash script. So now what we can do is use a special character, and it's the greater than sign. The greater than sign will write. Now it will write. That's an important thing to know. But it will write this to that file. So it will write what's in quotes here to that file. Okay. I thought it would. It's not doing that though. Okay, it did set it here. You know what? I think what we need to do instead is we need to do echo, and now we do want the single quotes because we want the literal characters. Yeah, we need to use the echo to do that. Otherwise, it just runs the command. So now we have this file with that in there. So then the second command, echo with that single quotes, because we do want the literal characters. Now, if we use that same one and we go to there and we cat it out, we can see there's only one line in there now. It's the second line. That's because we're using the write operation. The append operation will add both lines in there. So let's use the append operation for the first statement. So that's just two greater than signs, and then cat out there. And now we've got two, so now we can just, instead of entering those both and being annoyed, we can do bash setup city collector ID, and then if I do echo path, we got everything we need in there to just run the city collector ID script. I think it does not seem to have worked the way I thought it would. Oh, it looks good to me. Everything looks good. Is it? Yeah, it's in there. For some reason, the wet ball project Didn't make it in there. I guess I'll try running the script again. Yeah, for some reason this isn't making it in there. Okay. Why isn't that first line making it in there? Actually, a better question is why is one of the lines making it in there, but the other line is not? Oh, okay, so neither line made it in there. There's a syntax error with the script, I think. My guess is that it needs the colon to know that there is 2 lines in there. So I'm going to try that. Then I'll run the setup. I'll run echo path so you can see that there's nothing in there right now relevant to the script. And then I'll run the script after I exit vi with my expert level knowledge. That's kind of a meme, is how hard it is to exit vi if you're not familiar with it. And oh, still same problem. Okay, well, what the heck? It should do it, right? Why is it not doing it? Anyways, we demonstrated the special character write and append, so that's what really matters. This didn't work, but that's not really the goal. I wish I could figure out why that didn't work. I'm just curious what is missing in my knowledge. Yeah, I'm really curious about that. Okay, what is missing in my knowledge there? I don't know. Yeah. Oh well. I don't know. I don't think it matters. It's kind of too bad that you can't just set things up like this. What if I use the ampersand? Still nothing. That's weird. Huh. I wish I knew why I was so confused about this. Looks legit to me. You know what? Let's ask the AI. Okay, so we've got to feed it another thing. Okay, so there's a syntax error. So I wonder if it's like I wonder if it's a sudo thing. No, that's not it. Okay, but there is a syntax error there that we have fixed. So the next thing is script execution. Oh, it has to be a. I think it has to be an executable. No, that's not it. Variable scope. Keep in mind that environment variables modifications within within a script do not persist outside of the script's execution. This is it. When you run the script, it modifies a path variable within the script's context. After the script finishes executing, the modified path variable does not affect the parent shell. To make the changes persistent, you can use source to run it instead of bash. Okay, so learn something new. We'll probably get to that later, but yeah, if I use the source command and then print it out, yep, now we see it's there. So now I can just run this CD collector script without having to go through that painstaking setup process, because it's just all in the script. But I gotta use the source command for that, not just bash. So I learned something new. That's really good. All right, so try running these special characters. Try running commands using strings made up of special characters and using various methods to escape them. Other differences in the way these methods behave. Let's just go right to the answer for that one, because I feel like over the course of this I went through that. So yep, here's a list. We got to list our own way, asking the AI and looking up online. Here we're just going to look at the answers for this and not really spend a lot of time on it. Escape, yeah, we already went through this and understand this fully, so we don't need to spend a lot of time on this. Escaping using double quote characters will preserve the special values of the $, a backtick, and the backslash. Escaping using a single quote character, on the other hand, will render all characters as literal. I believe escaping using a backslash will render all characters as literal as well. Let's do echo backslash path and backslash, not forward slash. Yep, and now the $, was interpreted as a literal character. Alright, so in summary, in this lesson you learned how to identify your system's environment variables, how to create your own environment variables and export them to other shells, how to remove environment variables, and how to use both the env and set commands. Remember, the env command is for the particular environment you're in, and the set commands are more system-wide. How to escape special characters, so bash will read them literally. You can do that with single quotes or a backslash. The following commands were discussed in this lesson: echo, print input strings and variables; env, understand and modify your environment variables; export, pass an environment variable to child shells; unset values and attributes of shell variables and functions. All right, we're almost at the 2 hour. We're past the 1.5 hour mark, which is amazing. I did take some golden root again today. I feel like it really worked well for me yesterday, and the proof is in the pudding for today. I almost made a 2 hour video here. And not only that, like, we really, in my mind, learned some valuable things about how Linux actually works. And we learned about these commands like path and env and set and source and what's the big one, export. We like actually learned in a full way and got an intuitive sense of these commands, instead of just kind of shooting in the dark or following some guide and just entering things in willy-nilly without actually knowing what they do. That's against the spirit of this channel. This channel is all about like having knowledge of what you're doing. So thanks for watching, and see you in the next video.